Hi Year 6, your turn for math skills today. So join me as we are going to work through 3 different types of activities, and we need this key vocabulary to support us with our explanations in maths. Because it's not just about doing, it's about knowing and explaining why. So this is the key vocabulary. We are going to be focusing on part, whole, percentage, decimal, fraction, equivalent, multiple, greater, rounding down, rounding up. I'm going to certainly be talking about the nearest multiple as well as we work through that final activity. So let's get started with our first activity. And this is an activity I know that you are familiar with. It's our variation facts. And we're going to be working from a completed equation here of 15 times 5 equals 75. So just double check that you're happy that that is a correct fact. Great, that is a correct fact. And we're going to use that correct fact that we know is true to help us solve other facts that we aren't quite as quick with. We're not as fluent with pulling those facts out. That's why we need to learn our times table so we can use that fact to figure out other more complicated facts, but ultimately make things easier for us. So this slide, you're going to help me as I solve these calculations. So please think out loud as we are working through each of them. So we've got 15 times 5 equals 75. I'm going to firstly look at 50 times 15, and I'm going to think, what connections can I see? So I can see the 15 being the same. However, the 5 has been multiplied by 10. Fantastic. So the impact that that's going to have on the other side of our equation is that is also going to be multiplied by 10. So we've got 75 multiplied by 10. 75 tens is 750. So thank you for your help with that. Moving to the next calculation of 500 times 15. Again, I'm going to look back at my red calculation there, see what is the same, see what's different. That's the same. However, 500, this has been manipulated by 100 times more, meaning the other side of my equation is going to also be manipulated 100 times more. So now I've got 7500s, which is also read as 7,500. Can we see the impact this has had on this and the impact this has had on this to balance that equation out? Great. Now I'm going to look at 30 times 5 against 15 times 5. What relationships can you spot? Great. Should hopefully have spotted the relationship between 30 and 15. 30 is double 15. So part of this equation has been doubled. What's going to happen to this side? That's also going to be doubled. So hopefully we're able to pull out 75, what double 75 is. Some of you might know double 70 being 140 and double 5 being 10. We can put 140 and 10 together to get, yes, 150. Great work if you managed to pull that fact out nice and rapidly. We should hopefully be knowing double 75 is 150. Now, 1.5 times 5, looking at the connection at the top, what can I see? Actually, part of this side has decreased by 10 times. 10 times decreased there. So meaning this part of the equation, this side of the equation, to allow it to balance, must also be divided by 10. Just like this value here has been divided by 10, this side must also be divided by 10. So 75 divided by 10 is 7.5. Fantastic. We can see a shift of that place value there. Now, as we move to this side, we are going to be looking at 2.5 times 15. What connections can we see? Well, we can see a connection between 5 and 2.5, hopefully, and it's half that value. So because part of this calculation is being halved, we must mean that this part of the calculation must also be halved. That has the same impact on both sides of that equation. So half of 75, half of 70, 35, half of 5 is 2.5, add them together, you get 37.5. So don't be afraid to partition off, do the work and then bring it back together. That's a real good way of being efficient with your maths. Then we've got 75 divided by 5. Quite an easy one when we're looking at our fact families. We can see that the impact is just going to be 15. It is just an inverse operation there. Then we look at the division calculation. So the other division calculation we can see from the fact family will be 75 divided by 15 is equal to, yes, 5. And it looks like this calculation is working from that fact family there. So we've got 750 divided by 1.5. What has the impact been? We've got an increase of times 10, but here, so we've got an increased value of times 10, however we're dividing by a decreased value of divided by 10. So we've got a decrease here and an increase. So we've got an increase of the whole by 10 and a decrease of the part by 10. So that actually has a by 100 impact there. So we haven't got the value of 5, we're going to have the value of 500. Can we see that? So because we've got a larger value and we've got a smaller value to divide by, we're ending up with a bigger value in each of those parts. Then we've got that final calculation there. I'm going to give you a moment to have a little look at that one. Think about the impact that's happened here. Think about the impact that's happened here. It is a multiplication, so what is the impact going to be on this side of the calculation? You spend a moment explaining that. Right, what did we find out? So looking back at the fact family calculations, we can see this has been divided by 10 and this has been divided by 100. So we've got a division by 10 and a division by 100. So putting them together, yes, that's having 1,000 impact, isn't it? So dividing by 1,000. So if we've got our answer of 75, but we're dividing that by 1,000, we'll have 1, 2, 3 places different in our decimal point there. Okay, so we've got a value of 0.075. Fantastic if you've managed to solve that one. That's been a lot of me talking and me explaining. So now I would like you to look at this calculation. So we've got an equation here that is completed. 144 divided by 12 equals 12. And I would like you to use that fact and the impact that's happened to each of these parts of the equation to figure out the other part. Okay? Think carefully and explain the impact as you go through. Off you go. Pause the video to allow yourself more time. Right, so what we can see, looking at the inverse, we've got the multiplication side of the calculation here, 12 times 12 being 144. Hopefully we've spotted the relationship there that this has actually been halved from one of these values, so meaning we're going to have to halve our answer there. So some of us might halve 100, get your 50, half the 44, get your 22, 50 and 22 is 72. Great work if you managed to get that. Then we've got 1,440. What's happened? What has happened? It's increased by 10 times, but also the divisor has increased by 10 times, meaning that the answer will actually remain the same. We've got a value that is 10 times bigger, but also what we divide it into is 10 times bigger. So that's already balanced for us to remain the same. We can see the impact of actually dividing by 100 here, and again dividing by 100. Yes, so the impact there is actually of 10,000. So we look at our answer of 144, and we've got to move 4 place value points, 1, 2, 3, 4, meaning we got a 0 there, and we've got our 0 for our ones column. So great work if you managed to represent that correctly. Looking at the relationship again, what can we see? What can we see? We can see that one part has halved and the other part has doubled. So what impact is that going to have? I want you to spend a moment just to explain that to the person standing next to you or sitting next to you. Yes, so with that being the case, we've got to balance out. One part has been halved, one part has been doubled. So meaning we will get the same value there. So fantastic if you managed to spot that calculation relationship. Here we've got an increase of, again, times by 10. So this has been multiplied by 10. However, this part has actually remained the same. So we've got a larger value, but divided by the same, meaning that inside of each of those parts, there is going to be a 10 times increase in that value. Then we've got 144 remaining the same. However, it has been divided by a value that is 100 times smaller. So it's 100 times smaller, meaning that we're going to have more of those parts. So we would buy 100 times bigger there. Okay, and finally we've got that calculation of 1.2 times blank is 144. I want you to explain how you've managed to solve that one. Off you go. Great, so we've looked at which calculation. You might have gone straight to this one over here and thought, right, what has adapted? Actually, this has stayed the same, and this has, yes, decreased by 10 times. So what's going to have to happen to this side? That's decreased by 10 times. We're going to have an increase of 10 times to make that balance, to get us back to the answer that we know is accurate there. So great work for checking those relationships as you're working. Now, here is another fact for you. Instead of me giving the facts that you should know, I would like you to show me the facts that you know because you know this fact is true. So 25 times 6 is equal to 150. You've got time now to write as many calculations that you know because of this fact here. Off you go. Right, looking at the calculations we know, we go straight to our fact families. So because we know 25 times 6 is 150, we also know that 6 times 25 is equal to 150. We're then able to figure out our inverse. We're looking at the division part of that family to be able to help us know other facts. Then there are plenty of ways we can play around with this calculation by manipulating parts of that calculation there. So we're looking at 25 times 6 equals 150. How if we make this 10 times bigger, we can make this 10 times bigger. If we make this 10 times bigger, that also needs to go 10 times bigger, meaning the total's increased by 100 times bigger. We can also make it 10 times smaller, 100 times smaller, and we know all of those facts as a result of that. We can look at half facts as well. So you could have half 6 divided by 5 on the 25. There are lots of different facts you know by just stopping for a moment, looking at the relationship and trying to figure it out. So well done, and get an adult to check some of those calculations that you've done, or you could do it yourself on a calculator. We're now moving to our activity 2, where we're looking at fractions, decimals and percentages, where we're looking at a whole amount and finding a specific part of that amount and how that can be represented with either a fraction, a decimal or a percentage. So remember, we're playing with a whole amount and trying to find a part of that and showing it as fractions, decimals and also percentages, knowing that they can also represent that same part in different ways. So first of all, looking at my representation on the board, I've kindly told you we have got 93 out of 100. Am I accurate with that? I want you to just double check for me. Yes, fantastic. If you've managed to spot that actually this doesn't represent 93 out of 100, this represents, yes, it represents 83 out of 100. So great work. Some of you might have recognised actually it can't be 93 because I can see a whole 10 at the bottom there in your hundreds grid, and you've got 7 remaining there. Some of you might have counted down in tens and added the 3 and realised there were only 8 tens, which is great. We've got 83 out of 100. And I'm going to work with this slide just so you're familiar with the activity, and then it's going to be over to your turn. So we'll start off with 83 out of 100. I'm going to go work with fractions because I've worked with fractions for longer. So out of 100, I know that I've got 83 out of 100, and that's how it can be shown as a fraction. Fantastic. And as a percentage, percentages are taken out of 100%. 100% means one whole. So if everyone got a piece of cake, 100% of the people got a piece of cake. That means our whole. And actually, of this shape, I've only got 83% of it coloured in. So that's how I'm going to write it as a percentage. 83%. 83 out of 100. And as a decimal, we need to think of our place value. I'm just going to shift that up a little bit. And our place value, we're so good at working with hundreds, tens, ones. Then we have a decimal point, and after that we have parts of whole numbers. We have tenths and we have hundredths. And looking at my representation, this grid lends very well to hundredths because there are 100 individual parts. And we've already found out that there are 83 hundredths of that grid. However, in our place value, I can't write 83 hundredths in that hundredths column. 83 hundredths goes over into our tenths column as well. I want you to explain why. So why does that 83 hundredths end up coming into our tenths column? Off you go. Fantastic. Hopefully we've heard the word same there. So where we're looking at 83 hundredths, 83 hundredths is actually the same as 8 tenths. So we can see those 8 tenths. 1, 2, 3, 4, 5, 6, 7, 8. 8 tenths and 3 ones. 3 hundredths, should I say. 8 tenths and 3 hundredths. So we've got 8 tenths, 3 hundredths. It's just the same if we were to partition the number 83 into its tens and ones. we'd have 80, which we know as 8 tens, and then we'd have 3, which is 3 ones. It's exactly the same, but with parts of numbers. So we've got 8 tenths and 3 hundredths, because 80 hundredths is the same as 8 tenths. Great work if you managed to recognise that. Now I've had a go. It's up to you. First you check my representation matches my sentence at the top. Then I would like you to represent it as a percentage, a decimal and a fraction. And if you can simplify that fraction, if it's possible, you can do that as an extension. Off you go. Great, we're back in. Did we spot, was it accurate? Yes, we're happy that it's actually shown 53 out of 100. You might have gone to the fraction first, just like me, because the 100 is there. We've got 100 parts all together in our grid, and 53 of them have been coloured green. Okay, then we think about a percentage. A percentage is out of how many? Again, that whole would represent 100, so that's why this grid is fantastic for us to see the relationship between a fraction, a relationship between a percentage, and a relationship between a decimal. So we've got 53%. Fantastic, so the percentage is 53% there. And then finally, with our decimal, again, moving this up and thinking about our place value, 100, tens, ones, tenths, hundredths, what can we see? We can see 5 completed tenths, or 50 hundredths, and we can also see 3 hundredths, or 53 hundredths. Can we just write that as our number? No. We need our place value holder there. We've got no holes, there's no completed grids anywhere. So we've got 0, ones, 0.5 tenths, and 3 hundredths, 0.53. So fantastic if you managed to get that calculation there. This time we're playing with a different value here. We've got it represented in our grid. Remember that grid is great for linking the percentage, the fraction and the decimal. However, as you are representing them, I want you to make sure that you're simplifying the fraction to the smallest form. Okay, off you go. Pause the video if you'd like more time. Right, we've got 70 out of 100. Firstly, is that accurate? We can see the 50, 60, 70. Yes, so we're happy that it's 70 out of 100 shown in our 100 grid there. We could write that as a fraction of 70 over 100. 70 over 100, great. We can write that as a percentage, 70%. Fantastic, 70 of that 100 grid is coloured in, that's 70% of the grid is coloured in. Then, looking at decimal, we know our place value, we're good with that place value. So we've got hundreds, tens, ones, point, tenths, hundredths. How many hundredths can you see? 10, 20, 30, 40, 50, 60, 70. We can see 70 hundredths. How do we write 70 hundredths? It ends up going into our tenths because 70 hundredths is the same as 7 tenths. Would this be accurate? 0.70? Mathematically it is accurate. However, we don't actually need this 0 here. If we can't see any individual hundredth, it doesn't need to be there. Both are accurate, so if you've got 0.7, you've got 0.70, they are accurate. However, we don't need that 0 there. It's not essential. We do need this 0 as a place value holder. We're not finished though. We've got our fraction, we've got our percentage, and we've got our decimal. But when working with fractions, there are different fractions that can equal the same. Does anybody know the word for that? Yes, it's equivalent. So we're going to be looking for other fractions that are also equivalent to that until we can get them in its more simple form. So for us to find equivalent fractions, we need to find common multiples for both the denominator and the numerator. And a common multiple would be, yes, 10 goes into both the denominator and the numerator. And it goes in 10 times. So we divide that by 10 and we divide the numerator by 10 and we get 7/10. Fantastic. Now we're going to look for even more common multiples. Right, 7 we know is a prime number. You only multiple 1 and 7. Does 7 go into 10? No. So meaning that 7/10 is actually our most simple fraction. So fantastic if you manage to firstly do that, but also explain your reasoning behind why you did it. Another for you to be working on, look at the grid, check I have counted it correctly, put it into a fraction, put it into percentage, put it into decimal, and then simplify your fraction, making sure you explain every step as you go. Off you go. Pause the video if you'd like more time. Fantastic. So yes, we've got 35 out of the 100 squares coloured in. So we can write that as 35 hundredths in a fraction. Great. Percentage, that would mean 35% of that 100% whole has been coloured in. So we've got 35%. Great. We can see that relationship there, can't we? We move to our decimal. We're thinking about that place value. Do we need hundredths? No, we can't see hundreds. We can see ones, tenths, hundredths. Be careful how we say that. Make sure we've got good pronunciation. What can we see? We can see 3 completed tenths, and we can also see 5 hundredths, or we can see 35 hundredths. They're both equivalent there. But what must we remember when we're writing decimals? That we use that place value holder in our ones column. So we've got 0.35 because we haven't got any completed green grids anywhere. So we've got 0 wholes, but we've got 0.35 as our part. Like we had 35% as our part, and like we had 35 hundredths as our part. Okay, so when we're simplifying this fraction, again, we must be looking for common multiples between our numerator and our denominator. And which common multiple can you spot? Yes, some of you might have spotted your 5 times in there straight away. So we're going to divide both the numerator and the denominator by 5. How many times does 5 go into 100? Goes into 20 times. How many times does 5 go into 35? It goes into it 7 times. Great work if you manage to spot that relationship there. So can we simplify 7/20ths any further? So with us having 7/20ths, we look at 7 and we spot that it's a prime number. So a 7, can 7 be divided into 20? No, it can't. So we have actually got our most simple fraction there of 7/20ths. So fantastic if you spotted that there. What we've got now to finish up this activity of fractions, decimals and percentages is an incomplete grid which has either got the fraction, the decimal or the percentage given to you, and you need to make the rows of the grid match up. So the equivalent of the fraction in its decimal and percentage is required. Okay, off you go. Pause the video if you need more time. Right, I'm going to jump straight to the percentage. I know 17% of it means 17% of 100, so 100%, right? So our decimal, we know that we've got 0.17. In our fraction, we've got 17 over 100 at least. But then we look at 17 and 100? Are there any common multiples in there? 17 is a prime number, and no, 17 doesn't divide into 100. So actually we've got our more simple fraction already there. Then we might look at 45 over 50. Is it easy to convert into decimal percentage working at 50ths? What's going to help us out a little bit more? Yes, if we converted this to 100. To be able to do that, we have to multiply by 2. And we have to do that to both parts. So we've now actually got, what's double 45? Double the 40 gives us 80, double the 5 gives us 10. 80 and 10 is, yes, we've got 90. So we've got 90 out of 100, which we know is 90%. 90 out of 100 is 90 hundredths, or 9/10, which is then represented as 0.9. Some of you might have put the 0 on the end. Again, that's mathematically correct, however, it's not necessary. We've got 0.08, meaning we've got 8 hundredths, meaning we've got 8 out of 100, which means we've got 8%. And we've got 8 out of 100 as our fraction. Can that be simplified any further? Can we see any common multiples there? Some of you might have spotted 2 straight away. Some of you might have spotted 4. Yeah, so 4 goes into 125 times, and 4 goes into 8 2 times. Can it be shared any further? Is 2 a common multiple of 25? No, it's not. So we've got 2 25ths there. 0.22, got 2 tenths and 2 hundredths, or 22 hundredths, which is 22%. 22 over 100, what can we see? A common multiple of, yes, we can see a common multiple of 2 there, which gives us 50 and 11. 11 50th. Is there any more common multiples? 11 is a prime number. Does 11 go into 50? No, it doesn't. And then we're finished with our 2/5. Again, we've spoken about fractions and converting to decimals and percentages. We want to try and get to that 10 or try and get to that 100 to help us work more efficiently. So 2/5 relationship to get it to 10, times it by 2. So that's equivalent to 4 tenths. Oh, 4 tenths, we know 4 tenths. Must have 0.4 because that's our tenths column, 4 tenths. Well, actually, let's have a little think about it, 0.40. Oh, that must be 4 tenths, 40%. Great work. If you manage to see that relationship there. Good work. Now, third activity, we're going to be rounding up and rounding down. However, we're going to be really thinking carefully about what we're asking to be rounded to, which nearest multiple of. Because here we've got a 6-digit number. However, we've been asked to round to the nearest multiple of 1,000. Nearest multiple of 1,000. So that might mean we need to count now 1,000. So 1,000, 2,000, 3,000. Actually, here we've got 614,000, 615,000, 616,000, 617,000. That's us counting in thousands. 618,000. So, to round this to the nearest multiple of 1,000, we need to find out which multiple of 1,000 we're already at. We're already at 614,000. So we're already at 614,000. The next multiple of 1,000 will be 615,000. So we either need to round down to 614,000 or round up to 615,000. What is going to be at this point here? If we're at 614,000, 615,000, we're going to have 614,500 is our midpoint. So that's why we say when we're rounding, if the digit to the right is 5, 6, 7, 8, 9, we round up. And if it's 4, 3, 2, 1, we round down. Okay, so we currently know we're at 614,000. We know this number has 4 hundreds. We've got 5 hundreds there. So where will 4 hundreds place? It's going to place roughly here, meaning we are closest to 614,000, meaning we will round down. So that's why the 4 tells us we can round down. So let's finish this sentence together. When rounding 614,406 to the nearest 1,000, so a multiple of 1,000, we round down to 614,000, or we round up to 615,000. What tells us? The 4 hundreds tell us to round down. Fantastic. Because we know the 400 is before that midline. Midline and up tells us to round up. Below the midline tells us to round down. So that's my explanation of the one I've had to do. It's now your turn to solve this one. Again, you are rounding to the nearest multiple of 1,000. So which 1,000 are we at? Off you go to solve whether we round down and whether we round up and which value that will take us to. So pause the video if you need more time. We are currently at 752,000. So we're currently at 752,000, meaning our next 1,000 will be 753,000. You just need to get used to counting in those thousands. And now, in that midpoint, we know it's going to be 752,500. We should be seeing that 500 is that midpoint. So we know we're at 752,000. We know this value has 300. So is 300 going to be before or after 500? Yes, it's before. So meaning, because we know that that's 300, we know we need to round down to 752,000. Great work if you managed to recognise that. Again, helping me out. We are now round to the nearest multiple of 100. So nearest multiple of 100. So at the moment, we are at 614,406. So we're currently at 614,400 because we're looking at that 400 column. The next multiple of 100 will be 614,500. 614,500. What's going to be our midpoint for between 400 and 500? It's going to be 614,450. Midpoint is 50. Great. So then I need to look at how many tens have I got. Have I got 5 tens like the 50 saying? Actually, I've got no tens, meaning I'm so close to this side, I know I need to round down. So when rounding 614,406 to the nearest multiple of 100, we round down to 614,400, or we round up to 614,500, but the 0 tens, we're just going to put 0 tens, tells us to round down. And that's why we say when it's 4, 3, 2, 1 or 0, we round down. If it's 5, 6, 7, 8, 9, we round up. Great work. Now it's your turn. Again, to the nearest multiple of 100. So look at the nearest multiple of 100. Figure out where are we at currently, what will the next multiple be, and see whether we are closer, so we need to round down or round up. Off you go. Pause the video if you'd like more time. So we're rounded to the nearest multiple of 100. So we are currently at 752,500. We're currently at 752,500. 100. The next 100 would be 752,600. 752,600. Our midpoint would be in between 500 and 600 is going to be 550. So we've got 752,550. We look at our multiple of 10. What is it? It's 110, which is a value of 10, which we know is closest to this side, meaning we are going to be rounding down to 752,500 because we were rounding to the nearest multiple of 100. Great work. I'm going to leave you with this calculation to solve, and also I'm going to leave you with this calculation to solve. It is finding the nearest multiple of tens thousands. Nearest multiple of tens thousands. Off you go. Pause the video to give yourself more time. So we're looking at the nearest multiple of tens thousands. So we're looking at the tens of thousands column, and we're realising we're actually at 730,000 already. So it's 730,000 already. Meaning our next multiple of 10 is going to be 740,000. In the middle of 730,000, in the middle of 740,000, we're going to find 735,000. However, in our thousands column, we can see we don't have 5,000, we only have 2,000, meaning our number will lie roughly about here on our number line, meaning we need to round down. Fantastic. Nearest multiple of tens thousands again. We look at our 10,000 column, and we're currently at 680,000. So we're currently at 680,000. The next tens of thousand multiple will be 690,000. So we need to figure out whether we're rounding up or down to that value. And which value is going to tell us that? Yes, the number that's in our thousands column. If it was halfway, it would be 685,000. However, in the thousands column, we've only got 1,000, so our number is going to be even closer to that number, meaning we need to round down to 680,000. Lots of rounding downs today, haven't we? Good work if you manage to solve that, but show it on the number line, because that helps you understand why circling and identifying works. You've got this grid to complete, so you're looking at a number. You're going to be rounding it to the nearest 10, nearest 1,000, and also rounding to the nearest 100,000. So think very carefully about recognising the digit that you're focusing upon. Recognise the next multiple. So what is that current multiple? The next multiple, and find out where it lies in that number line. Okay, that's your final activity for today. I can't wait to see how you get on with that, so feel free to complete it and send a picture underneath the link. Thank you, Year 6. I hope you're staying safe, and I hope you really enjoy this math skills lesson. Bye.